Hello, in this episode, we are going to show how neural network is being created in PyTorch. Okay. So let's go to the Google Drive and neural network. So it's very similar to Keras, except you'll be importing Torch, the neural network related libraries. Okay. Okay, so in loading data, there are a couple of ways of doing it, but the most common way to do it is that you actually define a class. You can name it whatever you want, but MNIST data set. So you write your own program of class. Class is a group of variables and functions that you're going to use together. And MNIST, for the MNIST purposes, what do we have? So here, so init is just constructing the CSV file, read the CSV file here. But probably is more important is the get item part. So you get the 0 to 9 digit, the label from the CSV file you read in and call it label. The target is one hot indicator. So there are 10 indicators. Each of one of them will be 1 if for the corresponding digit. Okay. All right. And then it's the image data, isn't it? The image data is, well, we flatten it from 0 to 1 instead of 255. And we have that, except for the label, the rest of them here and call the image values. Okay, so we return that to get the item. So whenever MNIST data set is called, the label, target label, and the image value will be returned. Also, the data set has a function that plots the function here. So this is a class, and this is, if you're using a data set in Excel file, this is pretty much what you'll do. You can just modify this however you want it. So load the data. So we'll do it on Google Drive. Okay. And then here, MNIST data set, and then we'll go to my drive Colab notebook. And I already uploaded the MNIST train CSV file. So it will read in this MNIST train data. Okay. So MNIST train is actually a class. Okay. It's a class that if you have dot the label, it will give the label. And this class, the dot target, it will get this one hot vector and so forth. Okay. So for example, index 0, so MNIST train of 0, what does that do? Okay, so it gets this whole thing, okay? A 5, which is the indicator for label 5. So it's an image about the 5, and it has like the pixel images here, and then a one hot vector, which is the 5th one is tag 1, okay? And then in the neural network, actually, so now we have actually so we can plot it, of course. MNIST train of the plot image. The plot image was the last function here. So MNIST train of the plot image and then give the index. It will just plot the image here. The network also is defined as a class in neural network in PyTorch. And the way you do it is that first, the easy one to do is the sequential method. So you have a constructor in it, in the network class. Many of the things we use the preloaded by the Google programmer, what they already have done it. It's called an module, and it will have a lot of features that we can exploit. But we create our own name for it that borrows most of features of module, but we have some of our own also, which is the sequential network of linear from 784 to 200, 210, and then get the sigmoid, the middle layer was value. And a mean square error loss, optimizer. So these are sort of how you define your neural network. Okay, so it's a little bit fewer lines than Keras, but you can see that the sequential method defining the network structure, and then the loss function and optimizer, you define that. And then here is a forward pass. What do you do in a forward pass? Whatever the model is, the model forward with the input. Then you can train. The train function is, well, do the forward pass and get the output. The output is compared against the target and get the loss. And PyTorch can compute the gradients in any place, isn't it? So for the loss, we want to get the gradient of the loss with respect to all the weights, isn't it? So self-optimized at 0 grad means that we make all the gradients to 0. From the previous round, if it's not the first time running this, then there will be gradients calculated from the previous round. We want them set all to 0. Otherwise, they will stay. And the loss backward is compute the gradient of the loss, and then self-optimize the step will update the weights according to this gradient and propagate it. Okay. And we can plot the intermediate process in the plot if you want to. Okay. So here is a network class. And then let's train a network. So NN is the nickname for our network. Network is the class here. So it's a class. The NN our network has a NN is a network class with 4 epochs, and we are going to pull from the MNIST class, put the image label, image data, and target tensor, and then do the training, the NN train. We'll just use this, the NN of the train. So do the training, update the neural network, weights, and all that. So we are just do, let's say, 4 epochs. So it's gonna take a while. Let's just come back when it's done. Okay, it's done training. So let's see. So the plot progress, the history of the losses, we can plot by NN of plot progress. Okay, and you can see that it's kind of, there are points, but it's kind of settling down. So let's load the test data set, MNIST test data set, and here. So we picked the first one, which was 7 in the test data. So you can plot the image. Remember the class, we have plot image, plot progress. And in the data set class, we have the plot image. So we are just using them, which we already defined in a class. Okay. And then show one-hot indicators. So one of the item in the test was to get the one-hot vector, the 0 to 9. And which one is the highest? 7 is the highest value here. So you can see that it trained really well. Overall training performance was, well, we basically go through the test data and then get the answer and whether it matches with the label. So that's the same thing. And how many of them out of 10,000, 92,092 work correctly. So I think the training went really well. So this is one simple quick example of show how to do a neural network classifier for MNIST data. Thank you for watching this episode.